Sanjay Rajagopalan is a leader in the field of environmental cardiology. He's a director of the Cardiovascular Research Institute at Case Western Reserve.
The first thing I want to do is to frame the problem. It's a massive problem of defining what an exposome is. But the first thing I'd like to mention is we've really at a new era where rather than looking at one exposure at a time, shifted to a systems approach. And from a healthcare perspective, certainly over the last several decades, have moved from an individual risk factor approach, which was thanks to Framingham, dates back to the 1950s when the first publication of Framingham heart study was published, to a syndromic view in the 70s and 80s. But hopefully we moved to a systems view where we recognize that health cannot be examined individually, but has to be examined from the lens of where this fits into societal issues, economic issues, and environmental issues, and mental recognition of this alignment. And these are the factors that we are talking about when we start to examine the exposome. So hopefully we've shifted, as evidenced by the fact that the AHA, we have now many more sessions on the environment, to examining health from a wide-angle lens, which is not just focusing on measure within the human body, but a large proportion of factors that lie outside of the human body and yet influences health in a disproportionate manner. Social environmental systems of the nature that I just mentioned, one of the features that they exhibit is nonlinearity, and nonlinearity is to be appreciated because this again argues for a systems approach where you can't examine just one thing at a time because they're all interconnected. And if you perturb one factor, you measure one factor, you disturb another. There's feedback mechanisms. And we recognize this in physiology, going through medical school many years ago, that there are feedback loops, right? And this feature of nonlinear systems, they also tend to be dynamic and generative. And one way to look at this is the exposome as a rugged landscape of features that's constantly changing and exhibits all of these other entities. And therefore, measurement and assessment of the exposome has to recognize these types of systems. Now, there's a ton of data that we can get now, and we are in the era of artificial intelligence and machine learning. On the left side, you have all these exposure input data, which starts from large-scale monitoring data, satellite data, to microscopic micro environmental data, which obviously is much more expensive to do. But on the other hand, we have health inputs, which have really now gone on to multi-omic models. You can pick up any recent issue of Nature, and you can see the next best multi-omic model and prediction model that integrates epigenomic data, genomic data, proteomic data, et cetera. This has really resulted in a revolution in data science approaches, where not only can you put together environmental data together with health data, but you can also use a variety of different approaches that somewhat are dependent on dimensionality reduction and usage of a variety of different machine learning, artificial intelligence pipelines, decisions, and planning.